Hello and welcome to Spring's World. In this chapter we are going to cover the Spring core, and the first topic being inversion of control, which is also called dependency injection. So before we delve into it, let's do a quick recap of what we have already done till now. Till now we have seen the Spring background chapter 0, and in this chapter we have seen the various web timelines. We have seen why do we need Spring. We did a quick walkthrough of what was the technologies that were there in the beginning and how we actually ultimately evolved into Spring, and then we saw the actual course content that we are going to cover, and we saw a little bit of Spring setup and a quick hello world program to ensure that our workspace, our tools are all set for Spring tutorials. And then we also saw the design patterns that is used in Spring, based on which the whole application, whole framework is developed. So this was the Spring background. I'll just quickly walk through the rest of the stuff as well. The within web different timelines that we discussed, the first was the internet timeline, where we discussed the evolution, discussed the computer count, discussed the speed, and then we saw the first website, which was developed by Tim Berners-Lee, and he wrote the first HTTP protocol and HTML code along with the first web server, and also saw a little bit of background around HTML and XML. Then we saw the first browser. We also saw the commercial aspects of it, and then we started seeing the client-side technologies that evolved. We saw the history of W3C itself, and then we see the different browser evolution, the HTML timeline, the CSS timeline, and the different scripts timeline as well. And then we saw the client-side, server-side scripts, in which started with CGI. Then this is the Java world, and this is where we are. Somewhere around there the Spring started evolving. And then we also see the other parallel technologies that kept evolving along with the Java world, along Perl, Python, Ruby, PHP, ASP, all server-side stuff. And then another combination was the client-side with server-side, which was called Ajax. So we saw these, and then we saw the web framework timeline, different frameworks that came into picture, and the timeline associated with it. And then we saw Spring framework timeline itself, when was it first released, and then what was the different version associated with these release. So this concluded the timeline section. Then we saw why do we need Spring and the evolution. So we discussed the code sample using this use case, where we have the bank customer and the bank prospect. This is the anonymous customer, and this is a existing customer. So bank customer can go into the public area as well as secure area, and the bank prospect can only go to the public area. He does not have access to secure area. And we did the same thing using HTML, using CGI and Perl. We discussed how we do it in servlets. We also discussed what was not possible in it, why it was not good enough, why we moved on to it, then why we moved on to it, then why we moved on to it, and further this and this and this. Ultimately, why these were not good enough and why we ultimately chose this path was discussed in these code samples. So we discussed HTML, advantages of servlet over CGI, and then we discussed the containers a little bit, and the JSP container, then servlet versus JSP, then MVC1 versus MVC2. Then we also saw the struts, what it brings, how is it better than the MVC1 and MVC2, and what kind of implementation of it, of the MVC. And we also saw the different code associated with this. Then we saw the various components that is provided by Spring, and we also looked at the Spring course content that we are going to cover. So this is the chapter 1 that we are talking about, and we will be dealing with the first topic, which contains the bean factory and application context, which is nothing but an implementation of IOC container, which is also called Spring container sometimes, and sometimes it is called dependency injection. So, and the second chapter will be AOP. Third chapter will be the web tier, which is nothing but the Spring MVC, and then we'll see the data tier and data Spring security, what does it have and how we can use it. And finally the advanced topic, which includes remoting, web services, JMS, I18 and REST. And then we did a quick setup. We saw how to download the Eclipse, just provided the URL which was needed for version Juno of Eclipse, because that's what I'm using. You can choose to have any other version. Then we saw the URL for Tomcat as well. If you want, you can choose the instead of Eclipse plus Tomcat combination, you can use the STS plus VMware, which is built on Tomcat itself. Design patterns used in Spring are MVC, front controller, view helper, singleton, prototype, factory builder, templates and proxies. These are the things that we have covered till now, and now we are going to move on to the Spring chapter 1. Let's begin now. So lightweight IOC container, this is the focus now, and this is what we are talking about, core container. This is what we are going to cover. So to understand core container, we first need to understand what is a container. Yeah. So if you go by the dictionary meaning of container, it is just something which can hold something. Yeah, a dictionary meaning is anything that contains or can contain something as a carton. That's a container, right? So these are the different containers that we can think of. How do we use it in programming world? You must have heard of servlet container for sure. What does it hold? It holds servlet. It's a servlet container, yeah. Portlet container, what does it hold? Portlets. EJB container, what does it hold? EJBs. IOC container, what does it hold? Managed beans. That's what the purpose of container is. Web server is not just servlet container, it also takes care of the processing of requests. So it receives a HTTP request, it forwards the request to servlet container. Servlet container holds different servlets, it manages the servlet's life cycle, generates the response and returns the response back to the browser, right? So that's servlet container. We can see it's not only servlet container which is all available. So for example, if you are using Tomcat, which is a web server, so that will hold only a servlet container. But if you are using an app server, it may also have other J2E services and EJB container as well. These are all in a single server. So more than one container can live in a single server. Say for example here, if you can use a servlet container as Tomcat, and then you can use WebSphere application server as an EJB container. So you are using two different server to two different processing. Now you can have a single server which is providing you the servlet container and which is providing you the EJB container as well. If you have the servlet container, you can have IOC inversion of control container or Spring container on top of that itself. So now we understand the theoretical aspect of container. So let's see what this container needs. Servlet container is always the running program, and it says that if you want me to execute your applications, execute your web applications, you need to provide me your application in this way. Yeah, so this is nothing but the container configuration, which is also called web XML, web deployment descriptor. Within web deployment descriptor, which is the web XML, you define this is the entry point for the whole web application. The moment you upload a WAR in the web server, when we deploy the WAR in web server, it says that okay, I will look at the root of your .war. WAR is nothing but a zip file, web archive. It's a zip file, archive file. So assembly root, it says that I'll look for a web-inf folder, and within that folder I'll look for a file called webxml. If I don't find it, I can't help you. Right? I need to have my webxml file deployment descriptor to understand what you have provided within your WAR file. Right? So this web deployment descriptor actually gives the details of what servlets this web application needs to manage using the servlet container. So this gives you the details of all the servlets that this application has here. And within to serve those servlets, you have different artifacts. The artifacts like JSP, artifacts like dependencies, library, the .jar files, the different classes that you have written for your application, and the tag libraries. So these are the requirements for any web application to work under the servlet container. Similarly, the Spring will also needs its own deployment descriptor. Spring container will needs its deployment container and the associated files. Now that we have understood the containers and what containers need, let's see that how Spring container really maps with servlets as well. So what does servlet container manages? Servlet container manages servlets. Spring container manages beans. Servlet containers has XML. This web.xml name is fixed. That's the only difference. But in Spring container, you also need a servlet, some kind of deployment descriptor which tells the container what beans you want to manage, similar to what servlets you want to manage. The only difference is the name is not fixed here. What Spring container does for you, it does the routine and housekeeping tasks similar to servlet container. Servlet container manages Spring, initializes it, makes it available for service, destroys it when it is not needed, when it is removed. And similarly, Spring container manages beans for you. It does the instantiation, configuration and assembling of beans. In a servlet container you are managing servlet, in a Spring container you are managing beans. And Spring IOC is built on top of servlet container. Now we have understood the container, the basic concept of container. Let's quickly move on to why do we need an IOC container? Why do we need a dependency injection? I won't be able to explain inversion of control or dependency injection, these two terms which are used interchangeably, until next few slides. So we need to see the problems and we need to see why we need the Spring in the first place and what problems Spring solves. So the first problem is the tight coupling. So the use case that we are using is we have payment service. This payment service requires which accounts it needs payment from, and there is a method called pay, and it needs a saving account. And how does it get a saving account? There is a saving account component, there is a saving account object. What it does is this class has account number as instance variable and get details as a method. So when payment needs saving accounts, it does a new saving accounts, holds it, and then client calls pay on top of it. We have a payment service. Within this payment service, like we discussed, there are two things: the saving account object and the pay method with a constructor payment service. And in this constructor you are using new saving account, you are passing a random saving account number, and you are making this saving account available in the instance variable. So when somebody calls this public method pay, this saving account is available on this payment service, and this simply does a sysout. It says that payment process for this current account number. Saving account simply has this account number which has a constructor, and this has a get details method. That's what we have discussed here. So we have get details method and account number. So get details method and account number. We have payment service which has pay method and saving accounts. So pay method and saving accounts as instance variable, and ultimately we have client which is calling pay. So we need to understand this use case carefully, because I will be using this use case for quite a lot of things. It's very simple. We have a payment service which needs a saving account, and payment account, the saving account is directly created inside the payment account which is used by the client, which calls pay. Right? So how do we do it? We have this payment service. Whichever application needs this payment service, you will instantiate that payment service, which will instantiate the saving accounts in turns, provide a value associated with it, and then this will call pay. The pay will simply call this method and extract the value from saving account. So let's quickly run this method, which is a main method. So when this client calls payment service, what is called? Payment constructor is called. Then payment constructor needs saving accounts, so saving constructor is called, and once that is done, payment object is returned, and this payment object, pay method of payment object is invoked, and finally this method is displayed, and this dot saving accounts dot get details gives you this value. Simple. The problem. Now the problem is these two are very tightly coupled. The service and the on which the service is being executed and the client itself. There are too many news going on. So if I change this, say for example, all of a sudden I say that okay, I won't take the string s as this, comment it out, and set account number will say okay, I'll call set account number, and this is how I'll take the parameters. That's a quick change. The moment you do this change, you see the impact right here, right? Your payment service needs to be changed as well. And similarly, if you do something in payment services, your client needs to be changed as well. So that's the first and foremost. The changes, this is so tightly coupled that any change in anywhere in the system should be accompanied by other changes in the system. So what would you do here? You would simply call this constructor this way, and you will say savings account dot set account number. That's how you're going to change it. You'll pass it in a different way. It won't make any difference. The code will still execute. The only concern is that payment service will be called, then instead of constructor, the setter will be called, and finally the payment will be called. So that's the problem here. That's tight coupling. How do we resolve this problem? There are two solutions that is provided in core Java. Nothing to do with Spring. These are all core Java concepts. It says program to interface, and it says use factory design pattern, right? So let's see the first solution, how we work it out. The first solution is program to interface. Now instead of I have 3 accounts, an interface which says I am an account, and whoever implements me will implement get details, right? So we have current account implements get details. So 3 types of accounts are implemented using this function. They all have their own get details. Saving accounts, loan accounts, current account are all implementing accounts. Now we have the same payment service and the same client. In this payment service, what we are doing, we are saying that if while constructing the payment service, if user says that okay, I want to do payment using saving account, you pass the saving account, I'll do a construction using this user account and loan account, right? So there is a if then else, and at the runtime the user will decide whether to use saving accounts or loan accounts or current accounts, and that is being implemented by the interface. So I am programming, my instance variable is interface, not the implementation itself, right? So I am programming by interface here, right? The obvious benefit of it is we are still doing the new, but this will simply say this won't bind me with the implementation. So if I have, say for example, a new saving account altogether, a new type of account, say within loan account it is extended by a mortgage account, so I'll have a mortgage account here, and this instead of loan account I can simply say new mortgage account, and this constructor will change. This does not solve much of our problem, but it still from tightly coupled it converts it into loosely coupled system. So this system, the ones we were talking about here, instead of saving account, now we are not dealing with savings, we are dealing with account only, and this account can have 5 different implementation. A new implementation comes, it won't impact my code to that extent as it used to do earlier, right? So what I'll do is I've simply extended this code a little further. Payment service is nothing but payment service. The only thing is I'm asking user to give the choice, what kind of account the user wants to use for the payment. In this piece of code I'm simply scanning the user input. I'm asking user which account do you want to use for transaction, and user enters something and I'm extracting it and I'm returning it back to the constructor of payment service. And this account type is passed. If user enters S, I'll provide him the saving account. If user enters L, I'll give him the loan account. If user passes C, I'll provide him the current account. And then finally, when the pay is called, I am only working on the interface. I'm not saying the savings account dot get detail or loan account dot get detail. So even if I pass a new type of accounts, I don't need to change this piece of code. So let's quickly run this piece of code. Obviously, what are we expecting? This main will be called, the payment service will be called. Before that, the get user input will be called, and it'll say which account do you want to use for transaction. I'll say current account, right? So what it will do is, it will C will be inserted here, right, and it will use current account X789, and then finally the pay will be called. This pay will be called, so that current account will be passed via the interface, and get details will get you a 789. Before, you must be using if then else here as well, remember. So this is the first solution, which makes the tightly coupled code a little bit of loosely coupled. And the second solution that we were discussing was the factory design pattern, right? So before we delve into the code of factory design pattern, we first need to understand what this design pattern is. This design pattern is what it does. It's a creational design pattern, one of the GOF patterns. It creates things, right? And what is a factory? Factory is a building. The dictionary meaning of factory is a building or group of buildings with facilities for manufacturing of goods. If we talk in terms of the programming world, using factory design pattern, we create or manufacture, instead of goods, we manufacture objects. So factory design patterns is a creational design patterns which helps you in creating objects without polluting your code. We have the same, the current account, loan account, and saving account. What was the bad thing here? In this payment service, we were doing a lot of if then else, and that was our problem. We were still doing new inside the service itself. If a new type of account comes in, we'll have to change this code. This is the dirty bit. I don't want to impact my application if a new type of object comes in, or if the constructor of saving accounts changes, or say if the constructor says, okay, I want saving accounts using the setter accounts now. This is the very important concept. I don't want this loose coupling, even the loose coupling on top of interfaces. So I need what? I need a factory. I'll tell my factory, give me my object. How you get the object, how you initiate the object, it's not none of my business. I just need the object, right? So what you do is, you create an accounts factory, and you move this if then else into the account factory. And the account factory is responsible for doing new, is responsible for managing a new constructor of saving accounts, is responsible for managing a new type of objects that is defined in this hierarchy. So it manufactures accounts. What this account factory does? It will manufacture accounts for you. What will change? Your payment service will change drastically, right? You're still passing the payment service constructor, and now you're saying, I'm not talking to accounts type directly. I don't have any imports of accounts here. I'm just playing by interface. Apart from interface, I don't want to do any news of the new types of accounts. I'll go to my account factory and I'll say manufacture accounts, and I'll just pass what I need. I don't care how you get it, how you initialize it. Factory will take care of the manufacturing of account. Based on the account type, the account will be manufactured, and this will be given to the user account. User account is interface, and then you call the interface. Your client calls the interface. This is nothing but factory pattern. What you have done, you have given the responsibility of managing the objects, initializing the objects to the account factory. So what happens? I'll run this code. You won't see any difference in the output. It is exactly the same as the interface solution sample we saw. I say yes, S, and this S does what? And the user inputs gets you S. This S is given to the manufacturer accounts, and because it was S, you'll get saving account, and this saving account will be created. Manufacturer accounts will return the manufacturer accounts here in the payment service, and this will be assigned to the user accounts. When your client calls the pay on this user account, this pay will return you x123. Absolutely no difference. But what is the benefit? The benefit is, all of a sudden, note this, yeah, all of a sudden, if I say for example have a graduate or student account, say for example, student account implements account number as well, and it has one extra parameter which says substitution, right? It probably has a getter setter, generate getter setter. Okay, so it's a new student account. Now let's see how my service client, how my application, what is my application? It's a combination of client and payment. How my client and payments changes. Do I need to do any change here? No. Do I need to do any change here to incorporate? No. I just need to do a quick change here, which will say if you pass T, I'll get you student account, and that student account will be say 111. See the magic. I do a right click, I say run as, I said this, I'll just pass T here. The moment I pass T, what it does, it gets you a student account and it returns it to the payment service. Because we are running by interface, it doesn't matter to us. Get details will give you the details of student account. See the neatness. You did not have to change your application, neither your client nor your payment service. All you needed was a new student account was introduced. Your factory absorbed all the changes, right? And anything that associated with this new type of account, you directly are, you will simply use it. I'm not saying your application code won't change at all. It will change, but just to use your application rather than modifying anything existing here at all. Or say for example, saving accounts change all of a sudden. It says, okay, I don't want this constructor. Yeah. So what will be impacted? Only your factory will be impacted, and in this factory you will say, okay, I just need this account via setter and getter. So I'll just go generate a setter and getter using this account number, and in the account factory I'll say user account dot set. I'll just do a curly braces here. User account dot set account number x123. Any change, anything that changes will remain here. And then user account saving, you just assign this user account is equal to absolutely no change. You just run the application, you say savings, it'll get you the stuff, right? See the magic. We introduced a new types of saving account, we modified the saving account, my application code, my payment service remains untouched. That's the beauty. So that's what we are trying to solve. So we are trying to solve the tight coupling between systems, and the first two ways we did was the first solution was program to interface and used factory design pattern, right? So we just saw how we solve this. So what is factory design pattern? If the client needs a set of products using common interface accounts, and different set of products is mortgage account, loan account, student account, saving accounts, current account, but instead of creating it directly using new operator, it asks factory for a new product, providing information about the type of object it needs, like S, C, T. I need this. I don't care how you get it, just get it. Yeah. So you may know ahead of time what objects you might need. That's then you need to use factory design patterns and creates object without exposing the instantiation logic to the client. New, I don't care about how you set the values. I don't care about how you use the new operator, what constructor you use. Client does not need to know all subclasses and implementation. I introduced mortgages. I don't care about any of the implementation as long as I am playing by interface. I don't need to know all of its subclasses. In the example we just saw, we saw that I was not aware of the student classes when I was writing the code itself, and it was introduced and it was used simply. It encapsulates the object creation process. It simply hides, it encapsulates, it puts the whole thing in a capsule. When we say encapsulate, and you are hiding it from the outside world. So you encapsulate the object creation process in the factory design pattern, and it introduces weak coupling instead of tight coupling by hiding concrete classes from the application if you are using it by the interface. Introduction of new implementation becomes seamless. Only factory needs to change, as we have seen in the example. So you clearly understand what problem we are trying to fix. We have not come to IOC yet. These are pure Java design aspects. So we are trying to reduce tight coupling. We still have some problem. Even if you do program by interface and if you do factory design pattern, we still have problem. What is the problem? We have loose coupling and we have pull mechanism. Payment needs accounts. It creates it. Payment needs another service, database. It creates it. I need it, I'll get it. It's the responsibility of object A to fetch what it needs. So it's a pull mechanism. Another problem is application still has dependency with coupling using new operator. You must have seen that we are still doing, client is still doing the new payments. Yeah, so you can't keep on going creating factory for each and everything. And in a system there are thousands of objects, thousands of classes. You can't create a factory of everything because you don't need multiple types of each and every object. So it still has dependencies with coupling and it is still using the new operator. Another important aspect is application is instantiating, configuring, assembling and managing object lifecycle. When the object will be initialized, when object will need what type of data, how I'll use it, and then finally how I'll garbage collect it, how I'll destroy it, how I'll get rid of it, and the scope of the object, that it is available to what part of the system. So you still have problem that you still have dependency, although it is loose coupling and you are still using new operators, and apart from that your code is managing the beans, your code is doing the instantiation, your code is doing the configuration, your code is doing the assembly. You're writing pure Java codes to do all these things. Dependency coupling, that is slightly different than what we have already seen till now. Yeah, let's see the quick example. This problem is resolved by injection. What is injection? Let's quickly see. Someone will create the saving account and someone will provide you the saving account either in the constructor or in the setter. So for example, if we have a setter getter here, source generate setter. So I am saying this is none of your responsibility. You don't care how you get the saving account. You just want saving account, fine. We will provide you saving account either in constructor or we'll get you set the saving account using setters. So application is not pulling what it needs. I am pulling what I need. Either I do a new saving account, or even in the factory pattern, if you go to the payment service, I am pulling the saving account. It's a pull mechanism. I want it, I'll pull it, I'll get it. What we are saying in the injection is that you are not supposed to pull it. You just say what you need. It will be pushed to you. How it will be pushed? Either it will be pushed inside the constructor or it will be pushed inside the setter. Loud and clear? Right. So that's what we are trying to do. And how do we do it? The way we do it is we introduce something called assembler in between. And what assembler does is assembler creates the instance of saving account and it injects the saving account inside the payment so that payment does not have to pull it. Assembler manages the saving account and pushes it inside the payment. Also see this client is not instantiating payment directly. Client says assembler give me the payment service. Assembler goes to payment service, initializes it, but before initializing it, it goes to saving account, creates an instance, pushes it inside the payment, gets the payment, pushes it inside the client call, and then finally client simply uses it. Client says give me the payment service. That's all it does. And assembler pushes the payment service inside it, either using the constructor method or using the setter method. That's what is injection. And what is this? Object A needs it, object A will be provided. Object A needs object C, object A will be injected. So this is called dependency injection. I have dependency on B and C. Assembler, the framework, will inject it to me. I won't pull it. It will be pushed inside me. It's like Hollywood principle, which says don't call me, we'll call you back. Yeah, so it's more of a, instead of pull, it's a push mechanism. And let's see the term IOC then. Inversion of control. Pull is what? I need it, I'll pull it. Who controls it? The needy controls it. My objects, my application controls what I need. The whatever I need, I'll create a new of it, or I'll go to factory and get it. Now the control is reversed. That is, control is reversed, and control has been given to the framework, control has been given to the assembler, control has given to the IOC container, that if object A needs it, you push it. Now the control does not lie with object, the control lies with assembler. So that's what is inversion of control. Object A was controlling what it needs. Now the assembler and the framework and the container controls what it needs, and that's what is inversion of control. Right? You clearly understand what is IOC and dependency injection now. We'll see a quick example. If we say Spring IOC and DI, that's what it is. The bean factory or the Spring context is nothing but your push mechanism, your assembler, and it is responsible for creating your saving account, creating your current account, creating your payment object, and giving you the client your payment object. So let's see how it translates into code. How does it work in setter injection? I'm creating a assembler. This is my client, this is my payment, this is my saving account. So the point is that saving account remains as it is, right? Payment changes slightly, and now payment is not calling, say if we go there, payment is not doing if then else, or in the factory payment is not extracting the account type. What it is doing is it just has a setter, says that somebody provide me the saving account because I need it for my payment. Client goes to assembler, gets the payment object, calls the pay method. Now this assembler, what it does is it creates the new saving accounts, it creates the new payment account. Within payment account it calls the set method and assigns the account into the payment and returns the payment. See, now assembling is also happening. You can choose to have a factory method here. Instead of this, you can call account factory. That code is not here, but you can use that. Account factory and new account factory. I can move the code here, so don't worry about the error that you're getting here. And I can simply say a new saving account factory dot get manufacture account method, and you say okay, just give me the saving accounts. You can do this as well, absolutely no problem at all. Who is assembling it? Who is injecting the account object inside the payment? This is the injection. Who is doing it? The assembler itself, right? So I'll leave the code as it is to avoid the ugly error. The saving account is created, payment account is created, assembler is creating these two things for you, and this is being managed. Payment account is being injected inside the saving account is injected inside the payment account, and your client just talks to the assembler, and it's assembler responsibility to create those two objects and manage the dependency between these two. What is assembler doing? Creating the objects and managing the dependencies between two, and in effect it is also managing some sort of life cycle as well, right? So payment object is provided, you call pay, it gets you stuff. I'll do a right click, run it for a basic understanding. No problem at all. It's exactly the same example. The only thing we have done is we have introduced an assembler which is instantiating the objects and which is managing the dependencies as well. How we can do it? This time what we have done is we have used the setter injection to create to assign the dependency. Now let's use the constructor. Within constructor injection, what we are doing is we create the saving account. Now you pass the saving account at the time of creation of the second object itself. That's the only difference. The difference between this assembler and that assembler is you create the payment account separately and you assign the dependency using the setter method. Here what we are doing is instead of setter method, you are passing it directly in the constructor itself. Absolutely no difference. You run the client, you get it using constructor injection. Let's move on to the final stuff. That's what is this combination of assembler and factory is nothing but your Spring Bean factory. And where is your assembler definition? This in Spring, this piece, the instantiation bit of these two objects and the management of relationship between the objects, that is defined inside the XMLs. So within assembler is nothing but depicted in terms of XML. We'll see later on that it can be done by the annotations or it can be done by the pure Java as well, but this assembler in a Spring world is normally inside the XML. In XML you say I have account object, this is new account object, I have a payment service which needs payment service, I have an account object. So this assembler saving account, this is the XSD which says define saving account and the variable name is account. This is nothing exactly the same. I'll just retranslate the variable name so that you can see the exact definition. So if I put this line here, this line is nothing but this line, and in your payment service you have a payment object. It is the setter injection. The example that is there is for the constructor injection. So in this XSD, this three lines here, and here is nothing but payment is equal to new payment, and in the constructor you pass the account object you have defined here, right? So these three lines are exactly as these lines. So your assembler is doing the bean instantiation and it is also managing the dependencies for you. So in your client, instead of calling the assembler, you forget about it. That's what we have already seen. So instead of calling the assembler, you say that okay, instead of assembler you are calling the XML bean factory. And what are you passing to the XML bean factory? You are passing this XML as your assembler definition, and then you get the bean factory and you ask the factory get me the payment object. So I have used beans.dtd.xml. I'll say get me my payment object. It will instantiate the payment object. In the constructor it needs account, so it will go and instantiate the account object. So it will do a new saving account, create a variable with the account, it will inject it into constructor of the payments, and ultimately the same story. You say pay and it does the pay. This is one thing that is called XML bean factory. Another thing is class path application context. So we'll see the different types of different implementation of this assembler. Sometimes assembler is called bean factory, sometimes assembler is assembler is improved upon, and bean factory is extended by the application context. So within application context you can have class path based application, XML based application context, file system based application context, XML based application context, annotation based application context, or web based application context. So these are various varieties of this assembler that we have just discussed. We'll see it later that what are the differences and all, what is the differences between bean factory and what enhancement do we get in application context. But for now you just need to understand your XML bean factory is nothing but your assembler which defines which instantiates all the beans and which manages the dependency and the life cycle of the beans as well. And ultimately, instead of calling assembler in your clients, if you see the previous example, in this what you did, you said assembler get me the payment object and you call the pay.pay. Here what we are saying is XML bean factory, take this XML as my definition. So XML is nothing but your assembler configuration. XML bean factory, take that assembler configuration from the file system, and this becomes your assembler. Now you're saying this factory assembler that you get me the bean, and this payment bean is returned, and this payment.pay is called. I'll just run it for the sake of clarity. In fact, I'll just comment these out to keep it simple. Yeah, so it defines the bean factory, load bean definitions from this location, and it gets you the payment object.